something called Cramer's rule. Okay? So the solution, this is going to be another method that you can use to solve a system of equations. We've got elimination and substitution. We've got the Gauss-Jordan elimination with the augmented matrices. This is going to be one more way that you can solve a system. So the solution of a system of equations, and we'll give the system something like this. We'll say it's ax plus by is equal to e, and then we'll say this is cx plus dy is equal to f. Okay, so that's just a system. All your coefficients and constants are these a's, b's, c's. Okay? I'm just using these to develop the rule, and then we'll do an example. So the solution is given by x is equal to determinant sub x, or big D sub x, over big D. And y is equal to big D sub y over big D. Okay? Now, what are these D's? Okay? Big D is the determinant of the coefficients from the system. So it's going to be big D is equal to the determinant. Okay, now what are the coefficients of my system? A, B, C, D. Okay? So all we're going to have to do is calculate. We'll plug in the numbers, and we'll calculate what this big D is, and then we're just going to plug it up in here. Now D sub x is the determinant with the coefficients of x replaced with the constants. Okay? So that would be, in this case, we're taking the determinant. Now, instead of the coefficients of x from here, I'm going to, instead of using a and c, I'm going to replace them with my constants, e and f. And then I'm going to continue to use the coefficients for the second column. So b and d for my coefficients of y. Okay? Any questions? So I'm just assigning what are these D's, these big D's. They're just going to be determinants of specific types of matrices. I have to formulate these matrices in this way for this to work. Okay? We'll do an example in a minute. Can you think about, just from your knowledge of dx, what do you think big dy is going to be? A, if you're going down, A, C, E, F. Yes, it will be. So what are we doing? We're determinant with what are we replacing? Well, for x, we replace the x column. For y, we're going to replace the y column with the coefficients of y, again replaced with the constants. And I'll go ahead, I'm running out of room, I'll put it over here. dy is going to be the determinant of a and c are still going to be there for our x column, a and c. But instead of using b and d, I'm going to use e and f. Okay? You guys ready for an example? Too much theory and not enough example? I'm going to move on, okay? So let's look at an example. So we want to use Cramer's rule to solve the system. Thought I had one picked out. X minus y equals 4, and then 2x plus y is equal to 5. So what's my big B in that case? Yeah, so the first thing we want to do is just calculate big D. Remember, that's just the coefficients of your variables. 1, -1, 2, and then another 1. Calculate that out. So 1 times 1 is 1, minus a 2 times a -1 is a -2. This is equal to 1 plus 2, which is 3. Everybody get that? Okay. Now, d sub x is going to be the determinant. But instead of using the coefficients for x, that's what the x down here is going to tell us. Instead of using those, what am I going to place there? Yeah, these constants, 4 and 5. So I'll put a 4 and a 5 there on my x column. And then I'm going to keep my y's, -1, 1. Now what is that determinant? 4 minus a -5, which is 9. Everyone try to write d sub y. What'd you guys get? 1, 2. You're going to keep the coefficients of your x in this left-hand column. This y tells me I'm going to replace the y column. You can think about it as the y column with, instead of using those coefficients, use the constants. 4, 5. Now just calculate it out. 1 times 5 is 5, minus 2 times 4 is 8. And it is -3. How many of you got that? Okay, good. Now the last thing that we need to do to use Cramer's rule is, now remember that x is dx over big D. So what is my dx? 9. My d is over 3. What is 9 over 3? So x is 3. Now my y is dy over d. dy is a -3. My d again is 3. So it is a -1. And what is the point? 3, -1 is the solution. Now you could have solved this with elimination or substitution or using augmented matrices. With a little practice, this is a very efficient way to do it. Any questions on that?